So let me introduce Christian. He's a programmer and musician based in Potsdam. And during his music studies, he became increasingly interested in creating improvised electronic music using his own tools. In this talk, we will explore the possibilities of building musical instruments with a terminal user interface using Rust and Ratatui. So give it up for Christian.
Thanks. Cool. Okay. Yeah. Hi. Thanks for giving me this opportunity here. I'm very excited. I haven't done something like this before. So yeah, this talk is going to be about audio applications with a terminal user interface. And so I will quickly talk about myself, who I am, and why I do terminal user interfaces, especially for audio. And then we will see some examples, like how I basically bring all this together. And we will see another sampler running in the terminal. And then we will have a quick look at a current project which I'm kind of exploring, which is VS-TUI. So I'm kind of bringing the terminal style UI to VST plugins, basically. Cool. So yeah, I'm Christian. I'm a programmer and musician. I studied music production and making music as clichés for multiple years already. And so I'm very interested in live sampling, which is where I improvise with a musician and I'm recording, like sampling live, and then I'm improvising with that material. And for that, it happened that I built my own samplers. Yeah, and here's a bit about my DIY instrument journey. So it all started out with Max MSP at some point, actually some years before Max for Live came out. And some years later, I got into the Axoloti. Anyone knows the Axoloti board? Yeah. So it's a super nice project. It's a microcontroller for making musical instruments, and it comes with this patcher basically. So you can patch it with, it's very like pure data Max MSP like, and then you can build your own boxes with that. And that brought me to circuit bending, and then Corona came, and I needed a project, and I built an analog synthesizer from scratch, and and then at some point I started to do some Arduino Teensy stuff and like becoming more interested into programming. And at some point at the moment, I feeling I was more interested in building stuff than using it, even though I still like to use my tools. And at some point also, it was Corona, and I switched my career actually, and from being a freelance musician to now I'm like working as a full stack developer. And just recently I started Time Rift Audio, which is like going to be my place where I want to like publish just the audio software that I'm building. So I have 2 plugins there at the moment, so there's more to come. Probably maybe some TUI stuff. Okay, enough about me. And so why terminal user interfaces for audio? So I had a bit of a journey, like until I started doing it. So I wanted to do something more with audio again after becoming a web developer, and I thought I always was interested in making hardware, and I had this crazy idea of making a hardware sampler, and I came up with just some stack, I don't know, and I thought it's a good idea to get a Raspberry Pi, run my sampler there, attach an LCD screen, and then run a terminal user interface on that, and then building a MIDI controller for the controls. And I thought, boom, I will have a hardware sampler. But it turns out it wasn't that easy in the end. But in the end, I had a sampler running in the terminal. And I thought what to do with that. And I realized it's actually working pretty well with a SuperCollider together. That was what you saw on the left side, which is like a live coding environment. So I'm using that in the terminal, and it's super fun. Then I realized to try to use the terminal for performance, and it feels kind of you're using a hardware device somehow, and you have a lot of flexibilities. So other reasons for a TUI could be that it runs generally everywhere, especially with this library or this crate, how it's called in Rust. It's a Ratatui, and we will look at that later. So Ratatui even runs on microcontrollers. So it's a super nice library. It's super lightweight, and I think the biggest point for me is that it's a very different way of thinking about UI design. So especially when, like me, having this web developer background. So as you can imagine, most of it I'm writing in TypeScript, like React or Vue, and then it's like there's like this idea of like what an UI is when you work with these kinds of frameworks. And then when you go making a terminal user interface, you need to think differently in some situations, because you don't work with a pixel buffer, so you don't think in pixels, but more in characters. So everything in the terminal is a character, basically. And then there are things you cannot do, like it's, or you need to find workarounds, or and then I had the feeling that it's actually beneficial for both sides, just now trying out something new, going like a different approach, and then, and it's super fun to build, and probably I think it looks amazing, so I really like the style. So that's probably the biggest reason. Cool. So how I built that stuff. So for the UI layer, as I mentioned, I'm using Ratatui. For the audio engine, like just for this standalone apps, I'm just using the Jack crate, and that makes it super easy to make the audio stuff. So in Rust, you would have an alternative that could be CPaul, which is a cross platform audio library. And at least at the time I was looking into that, it was a bit more involved setting it up, especially if you have to synchronize an input stream, an output stream, and then MIDI. And then Jack gives you all of that for free. So, and I was more interested in actually I want to make sound and not synchronize my stuff. So, so this is why I went with Jack. At some point I will look at CPaul for sure. Yeah, and then for the DSP side of things, basically I could do anything. So the Graniac, so the sampler was called actually Graniac. So it's written purely in Rust. I have another project where the DSP is just C, so basically everything can integrate in the setup. Yeah, and then I mentioned it here, like the sync model that I'm using is like a triple buffer to synchronize data from the audio stream with the UI. No, the audio thread with the UI thread. Yeah, and then there's also a very good library in Rust for that. Yeah, so let's look at some examples, like some code. So this is the Graniac sampler, the one that you saw in the little demo. Let's okay, so I can make this. Okay, so yeah, I have this building blocks. So the core is basically just the DSP part. We won't look into this today. Then what I like to do is then I write the DSP and then I have the possibility to like include it in different kind of applications. So I have a plugin with a GUI, and then I could just use and this is what the TUI, which we look at later. So it's the plugin with the terminal interface, and this is just the project, the standalone version that we've just seen, and some MIDI controller for this standalone thing that I mentioned. And so here, basically, all the dependencies are just Jack, as I mentioned. I'm using my DSP, Graniac, then Ratatui for the TUI. These 30, I don't know, 30 things. It's like for serializing JSON. So I'm using that to configure the Graniac sampler on runtime. So you can have a JSON config, and then you can do the MIDI mappings or the presets you can set there. And this is for that. Crossbeam is kind of like a channel thing that I use to. So I use the triple buffer for like most of the stuff getting from the audio thread. And then the crossbeam I use like to communicate some keyboard events, something like loading a preset or stuff like that. And hound is for writing or reading WAV files, basically. So this is when I want to persist a sample, I can save it. And this is what this library is for. So let's look just at the main function. And so this is just preset stuff. And so here just begins the Jack thing. So it's very simple. You just create a client, and then on that client you can define your ports. So then in the end it looks like, so you have this thing here, and this is out of the ports that you defined. And so, and then you get your audio callback with Jack. And the only thing, so I'm doing like some MIDI stuff and this listening for these keyboard events. But for the sampler, the only thing I need to do is call the render function on my sampler, and everything else is happening then in the DSP. So this is super portable, and it can like be switched out into different applications. And this is all for the audio, basically. So then you activate the client and it runs. So you need to some way to not terminate it. So then here starts the TUI stuff. And so in Ratatouille, there is this very convenient method. It's called init. And it initializes a terminal with reasonable default for most applications. And and these defaults work for me. So, and what it does is, so Ratatouille works with kind of a back-end system. So where you can write your Ratatouille code, and if you want to run it on a microcontroller, there's a backend for that, and you don't need to change your actual UI code. And here it's using by default the cross-term backend, which is a cross-platform terminal backend. But then there are like other, like a lot of community-based backends, like also for pixel, like buffer environments and stuff. And yeah, and then you start some kind of UI loop, right? And then there are basically two building blocks of the TUI, where you have like a state, and the state here just means the state of the UI. There's no sampler audio state. It's just which window do I see, and stuff like that. So I have the possibility. Oh no, it crashed because I zoomed in. Anyway, so yeah, so you have the possibility to change the window, and this is just the state of the UI. And then you have basically the UI where you write your Ratatouille code. And it's immediate mode, so it renders on every frame, the whole thing. And the way Ratatouille works is that, so there are many ways you can use it. So the way I use it is, so you have the possibility to define your layouts. And the layout basically just defines where you want to draw something in your buffer. It's like just a relative position in the buffer. And so one way then you could render something is by render a widget. So there is the frame render widget method, and there are a lot of widget that comes with Ratatouille, like graphs, just basic like text widgets. But you can very easily make your own widget as well. So let's look. So yeah, here I'm using the span widget for drawing some text, which comes with Ratatouille. And then the track widget is something that I basically made myself. So let's look at the track widget. So there I did like another kind of technique to draw something to the buffer. I still get my layout, right? But instead of calling this render widget function, I'm directly rendering to the buffer, which is also possible. So the buffer is just holds every information of the screen, basically, like every character. And then you can just like index a certain position and say, here, I want to draw an A or something like that. And so, yeah, and everything is like character based. And if you remember that I had this waveform kind of thing, which was just like, I don't know how to pronounce it, like this Braille character. And so the basic, and this what I said, you kind of need to think differently. So the way I set this up is that I have this Braille states. So these are all the characters that I needed to draw the waveform. And then I have different states, just like some kind of lookup table or something like that. Right? So this like goes from silence to like a full thing. And then this gives me a total of 11 states. And I have this states array that holds this character states. And then I get just basically I get a sample, which is between 0 and 1. And then with that, I can index the correct state, basically. So yeah, and in a GUI kind of environment, you would probably do it very differently. So this is what I really like, that you are challenged to think out of the box at some point. Same with like the grain animation, which is also indexing the buffer directly, and then it draws just an O in the color yellow. And yeah, this is how you do TUIs with Ratatouille. It's super easy. There's not so much about it. Yeah, and I want to give another presentation of another sampler that I'm working on. I think I need to make this smaller. Yeah, this is the thing. So you could probably add some check that the screen is wide enough and like render some kind of warning instead of crashing. I didn't implement that yet, so it crashed. But I'm the only one that used it so far, so so okay, I need to that crashed right away. Here it is. Okay. I need to actually plug that in to my system. Now it gets. Cool. Yeah. So now in the end, I want to show you also this VS TUI project. I had the feeling if you make a terminal user interface, it has to have TUI in the name. So that's a rule. So how does that look? Let's open some DAW. And so I already prepared that. So insert a virtual instrument. So it's Graniac TUI. So it's super like experimental. So but what you see is basically the exact same code that I running in the terminal. I didn't have to rewrite anything. It just needed to use this kind of like other backend. So there is this community project which is called like Soft Ratatui, which is kind of a backend for using Ratatui on a pixel buffer basically. So there are some things that are different. So the font is different, the background color is different because it's not using my terminal system font, but it's using something that you set up with the backend. And so, and obviously there are no mouse events yet, so you cannot drag. It's possible to implement it, but I haven't done it yet. What I have done is I added, like, because to prove that it actually works, I implemented 2 keyboard events to load audio. So let's do that really quick. Just this sample. So it loads audio, and I need to change the density that we see some more things. And then actually, yeah, it just make it a bit silent. So it's working as the terminal thing. And I just using this track widget, and everything and everything else is actually managed by this backend. So it was surprisingly easy to implement that. There's still a lot that needs to be done in order to make it like work, like mouse events, and you can like style it a bit more better. But I think it's super nice, different way of making a UI for VST. And yeah, if you were interested in the code, actually, so the whole Brainiac project is on my GitHub. So there is the terminal, the VSTs and stuff. So let's go back to the slides here. So yeah, we have seen the matrix sampler. And then, yeah, VS2. So I'm a bit behind here with my slides. So yeah, once everywhere means also it can run inside the door. And yeah, that's it, basically. Thanks for listening. If you want to get in touch, you can write me an email or find me on GitHub or ping me on Discord. Yeah, thanks for listening. Thanks for inviting me. It was super exciting. And yeah, hopefully the pizza will come soon.
Until then, are there any questions? Okay, quite a few.
Yeah, super nice project, super nerdy. I like it a lot. Regarding the interaction scheme, you said in the DAW there are no mouse events. Is that the same thing because you used your MIDI controller for all interactions basically? Is there like an interaction scheme for the TUI itself, like keyboard based or mouse based or something like that?
Yeah, so there are ways also to make it like to add mouse events in the terminal. I haven't looked into that because I don't need it. But as you can see, I can, or maybe I will open, I need to make this like this. So there are like mouse events that I have, so you can like switch the window. So here I have a little window to inspect presets. And this is like kind of a work in progress. I want to like see the audio samples basically. And then, yeah, as I said, you can like down here you have this kind of mode. So now I'm in the load preset mode. So when I press a number, I can select a preset. I don't just have one preset. And then you can save presets. So this is like how to interact with it. But mostly then I'm like the musical parts I'm doing with the MIDI keyboards. I made one try to make a sampler that I would play with the keyboard, and I realized it's not so convenient.
Okay, interesting. Yeah, okay. Yeah, thanks.
Yeah, thank you. Really amazing music as well. How do you integrate SuperCollider with the whole project, or how does SuperCollider control your
with MIDI basically? So I have this MIDI controller patch, and basically, so if you know SuperCollider, so you can make a pattern that sends out MIDI basically. Okay. And then I just have this MIDI in, and I have this SuperCollider MIDI out, and then this is how I communicate. Yeah.
So I have two questions. One is if instead I was not interested in terminal like UI, is it simple to replace it with different UI framework? And if yes, what would you recommend?
so beside making it in a terminal, or just for like a graphical user interface?
Yeah, some graphic user interface.
You mean with Rust or in general?
Yeah, with Rust.
With Rust. So I have one. I have actually a graphical interface version. Here. Right. So this is basically, so for the plugin part, there's this library called NIH plug, which is a super like kind of a wrapper around plugin APIs, and then you can basically you have the possibility to use all kinds of UI frameworks. So there are some integrated, and I'm using Visia. But there are many things you can choose from, like Iced or eGUI is another thing. So you can just pick a lot of stuff.
Okay, thanks. And one more question. As someone who doesn't know Rust and knows well C++ with well-established framework JAWS, what are advantages and disadvantages to switching to Rust?
Yeah, so my reason why I actually switched, because I struggled with learning CMake. So and I was using I actually had it as a slide and I took it out because I thought it was stupid, but so at some point I started using NeoVim, and and then I also learned like Juice, and then I wanted to use NeoVim for that, and for a month it didn't work, and with Rust it just worked, and I didn't have to learn CMake, and that's the unromantic reason why I chose Rust, basically.
Yeah, CMake can be painful to learn and use. Thanks a lot.
Yeah. One last question. Anyone? No? Then thank you, Christian.
Thank you.